Hello, sorry students. Our system got frozen. We were recording this also, and then the system got frozen, and we have to start all over every time. It's super frustrating sometimes. Okay, but it's okay. It's all good. Without much ado, let's begin. Now we are in chapter 4, part 2, and we said this chapter subsection is called the IEEE802.11 wireless LAN standard. Now let's take a look at them. Let's take a look at these standards that are used. Now let's take a look at the first overview. Now a typical computer network is normally using what we call the twisted pair cable and the optical fiber cable to connect a network, to connect a wired network. So every time we have a wired network, what we normally use is a twisted pair cable and a optical fiber cable. That's what we normally use. Now today, another media that is competing with this for high data transfer rate is the wireless. Is the wireless. When we're talking about LAN now, another media that is competing with the transmission of data, high data transfer, is the wireless configuration. And this wireless configuration is based on the IEEE802.11 wireless standard. Now here are the advantages of the wireless concept. One is the user mobility. User mobility. It's very flexible. User mobility in the workplace. Number 2 is the flexibility in the workplace, and number 3 is cost effectiveness, and which involve the networking media for use in the area that are difficult and costly to wire, area that are difficult to reach, and area that are very costly to wire. Okay, so this this amount to significant importance and advantage with wireless. One is user mobility, and number 2 is flexibility. Number 3 is cost effectiveness. Okay, now let's move on quickly. Now let's take a look at the benefit of wireless network. Now, in order for wireless network to be of importance or benefit to us, we must the network administrator must ensure that the network services are reliable and they are secure at the same time. So the network administrator must provide a reliable network and a very secured one at that matter. Okay. So in order for him also to have the network administrator to have a reliable network service, it means that the network administrator must have a good knowledge and a good understanding of what we call the wireless LAN. Must have a good understanding of the wireless LAN, both the configuration and the technologies that can be used with it. So the network administrator must have a very good understanding of the wireless LAN, both the type of configuration that can be used with it and also the technology that goes with it. Without this, then the network administrator cannot provide a reliable and a secure network. Okay, now let's move on quickly. And as such, if the network administrator can provide us with a very superb, reliable and secure network, having understood the configurations and the technologies that are used with WLAN, then it means that he will be able to examine the fundamentals of wireless networking and the standard that is used with this wireless network. The standard, the family name that is used with it, or family standard that goes with it, which is the IEEE802.11 standard. The IEEE802.11 standard. This IEEE802.11 standard, it's what is used in the wireless network. And the family members includes the 802.11b, 802.11a, 802.11g, 802.11r, 802.11i, 802.11n, 802.11ac. All these are members of the family as it were. Now quickly, let's take a look at the IEEE802.11 standard. This standard is built on or is defined across 3 ranges. Okay, the standard, the IEEE802.11 standard is defined or across 3 layers in our system, in our network system. One is the physical layer, the 802.11 standard is defined across the physical layer, is defined across the media access control layer, it is also defined across the MAC management protocols and services. Now let's move on quickly. Let's take a look at the first one, which is the physical layer. The physical layer, the IEEE 802.11 standard is defined across the physical layer by looking at the method of transmitting the data. In the physical layer, we holistically look at the method by which we can transmit the data across this physical layer. One of the methods for transmitting data is called the RF, radio frequency method, and the infrared method of transmitting radio signals, now or wireless signals. Okay, so that's that. Now let's take a look at still on the physical layer, but in the physical layer we've talked about the method of transmission of data. Now we want to talk about the technology that can be used with physical layer. Now there are 4 different technologies that we use with the physical layer. The first one is called the DSSS. The DSS is direct sequence spread spectrum. And then we have the FHSS, which is the frequency hopping spread spectrum. And then the third method or third technology that is used with the IEEE 802.11 is the infrared technology. The fourth technology is called the OFDM, which is called the orthogonal frequency division multiplexing. Orthogonal frequency division multiplexing. These 4 technologies are used with the IEEE 802.11 wireless networking. Now, the DSSS, which is the direct sequence spread spectrum, is commonly used with 802.11b and 802.11g. This DSSS, the direct sequence spread spectrum, is normally and commonly used with 802.11b and 802.11g wireless networks. Okay, the OFDM, which is the orthogonal frequency division multiplexing, is used with 802.11a. Now let's move on quickly. Now let's quickly look at the 802.11b frequencies. The 802.11b frequencies, first of all, use a 2.4 gigahertz frequency. That means the bandwidth for 802.11b is 2.4 gigahertz frequency. Okay, this is the range of frequency that this covers. And then it's also, one advantage it has is that 802.11b is shared by many technologies, can be shared by many technologies. One of it is the Bluetooth. It can be shared with Bluetooth, can be shared with cordless telephone, and also other wireless LAN, WLAN, or what you call the WLAN, emits significant RF noise in the 2.4 gigahertz range. Okay, then we also say a significant improvement in the wireless performance is available with the 802.11a. So after 802.11b, a big improvement is the 802.11a. One of the improvements is that the 802.11a has a higher data transfer rate, of 54 megabit per second, unlike the 802.11b. The 802.11b just have a data transfer rate. That means speed. When we say data transfer rate, we're talking about the speed of this standard. Okay, the 802.11b uses a speed of 11 megabit per second, while the 802.11a has a higher data transfer rate of 54 megabit per second. Uses a higher data transfer rate of 54 megabit per second. That's not the only advantage it has. It also has a bandwidth or a frequency channel of about 5 gigahertz. The 802.11a equipment operates in the 5 gigahertz range as opposed to 2.4 of 802.11b and 802.11g. 802.11b and 802.11g, they use the 2.4 gigahertz, while the 802.11a use the 5 gigahertz frequency. And also, it provides significant improvement with RF interference as well. Now, let's take a look at the differences between them diagrammatically. You see, the 802.11a, although has a higher data transfer rate, that's the speed is 54 megabit per second, 54 megabit, mbps, 54 megabit per second. Okay, it has 54 megabit per second, while the B, 802.11b, although can go a long range, has only 11 megabit per second. Now let's take a look at the coverage area. The coverage, this one can the distance this one can go is around just about 75 feet. This one can cover about 75 feet, the 802.11a. Okay, you see there is a trade-off. There is a trade-off between distance it covers and the speed. There's a trade-off. Although 802.11a has a higher speed and a bigger bandwidth, but the distance it covers, the coverage area, it's only a distance of about 75 feet. So there's a trade-off between 802.11a and 802.11b. While 802.11b has a speed of 11, which is small, 11 megabit per second, 11 megabit Mbps, 11 Mbps. However, it can cover a range of 100 to 150 feet. A distance of 100 to 150 feet. Okay, this distance of transmission, it's from about 100 to 150 feet. You can see 802.11b has a higher distance, can cover a higher distance, although the speed is slower. It's just 11 megabit per second, meaning 11 mega is million. 11 million bits per second can be transferred in 1 second. 11 million bits can be transferred in 1 second. Can move per second. Can be transferred in per second. Okay, that's that. But for this is 54. Although this one is a shorter distance of 75 feet, but it can transfer 54 million bits in 1 second. 54 million bits in 1 second. Okay, and the bandwidth of this one is so huge. Is 5 gigahertz. The bandwidth of 802.11a is 5 gigahertz compared to 802.11b. The bandwidth of 802.11b is just 2.4 gigahertz bandwidth. Okay, let's move on to the next one. Now, the 802.11g, another introduction of the IEEE 802.11 wireless standard is the 802.11g. The 802.11g. The 802.11g standard support the higher data transmission. So the G takes something from the A, which is the 54 megabit per second. G is like a dichotomy. It takes something from A, it takes the speed of A, but operates in the frequency, in the bandwidth of B. The G takes the speed of A, but operates with a bandwidth, the channel, the data transfer channel, the channel of 2.4 gigahertz. Of B. It uses the transfer channel of B. So you can see the 802.11g takes something from 802.11a and also takes something from 802.11b. What does it take from 802.11a? It takes the speed, 54 megabit per second from 802.11a, and also takes from the B, the G takes from B the 2.4 gigahertz frequency or bandwidth. Okay, then we say the 802.11g equipment is also back compatible with the B equipment. The G is back compatible with G equipment, meaning if you already have 802.11b equipment installed, then the integrating with 802.11g is very possible. But 802.11a and B cannot be integrated. The only advantage here is that the equipment of this one cannot be integrated to the equipment of A. A and B cannot be integrated. The only advantage is that there is no crosstalk emanating from both of them. There is no crosstalk, and there's no coupling, there's no interference between both of them, even if they are close to each other. That's the advantage that it has. They have with each other. Now the 802.11 equipment is back compatible with the 802.11b. G is back compatible with B. This means that the 802.11b wireless client will be able to communicate with the G. So B will be able to communicate with G, and with 802.11 client can communicate with 802.11g access point. And vice versa. Also, the 802.11g wireless client will also be able to communicate with the 802.11b access point. So vice versa. Both the client of B can communicate with the access point of G, and the client of G can communicate with the access point of B. Okay? So that's that. They are back compatible with each other. Now let's take a look at we say the advantage of this is that companies that already have existing B network, 802.11b wireless network, will be able to migrate to a higher data rate provided by the 802.11g without having to sacrifice their network compatibility. Or like when you're doing with A, you have to sacrifice the compatibility. This one does not have to sacrifice the network compatibility. In fact, some of the new wireless equipment support both the 2.4 gigahertz and the 5 gigahertz, both. Now, another introduction to the family is the 802.11n. Another introduction to the family of the IEEE 802.11 is the introduction of the IEEE 802.11n. Now, this wireless technology can operate in the same ISM frequency as the 802.11b and G. 802.11b/G. That's the 2.4 gigahertz, and can also operate in the 5 gigahertz band. It can operate in the 2.4 and it can also operate in both bandwidth. Can use the 2.4 bandwidth and also can use the 5 bandwidth. That's one big advantage of the 802.11n. Then a significant improvement of the 802.11n is the MIMO. MIMO means multiple input, multiple output. So MIMO uses a technique called the space division multiplexing, where the data stream is split into multiple parts, and these are called spatial streams. Each multiple part is called a spatial stream. Now, the different spatial streams are transmitted using separate antennas. The different spatial streams are transmitted using separate antennas. Now, with MIMOs, doubling the spatial stream doubles the effective data rates. If you double the spatial stream, you will have succeeded in doubling the data rate transmission. The downside of this is that there can be increased power consumption. The problem with this, the disadvantage of this is that power consumption is high. But the 802.11n specification includes the MIMO power save mode. So the new one now includes the MIMO power save mode, so that to minimize this problem that we said is a downside. The problem that is a downside, which is increased power consumption, now comes with a MIMO power save mode to ensure that power is not too super consumed, so that to solve the problem, so we can continue to advance and enjoy the advantage of 802.11n. With the 802.11n only uses multiple data paths where faster data transmission is required. Therefore, this enhance or ensure that the power is being saved. Okay, now let's move on quickly. Then let's talk about the 802.11n, which is another introduction into the family of IEEE 802.11. And the introduction is called the IEEE 802.11ac. 802.11ac. Now, this is one of the latest additions to the 802.11 family standard that is used with wireless network. Now, the 802.11ac technology operates in the 5 gigahertz. Remember, the 802.11n can operate both in 5 gigahertz bandwidth and the 2.4 gigahertz bandwidth. But the 802.11ac only operates in the 5 gigahertz bandwidth. Now, it uses a new version of MIMO technology with 8 spatial streams and has a channel up to 80 megahertz wide. So each channel will use 80 megahertz. Okay. So because it's separated to about 8, so each one we use, so which means we can transmit up to 1 gig, okay, or up to 1 gig. The speed can be increased up to 1 gig. This is called the multiple user MIMO. This multiple user MIMO use what we call the beam forming. Okay, beam forming. So we can categorically say that the IEEE 802.11ac incorporates standardized beam forming, unlike the 802.11n. Although the 802.11n also use what we call the beam forming. I'm going to talk about the meaning of beam forming. Although use a beam forming technique, but does not have a standardized beam forming technique. But the 802.11ac uses what we call a standardized beam forming. A standardized beam beamforming. Now, what is a beamforming? Beamforming is a technique that is used to direct transmission of a radio signal to a specific device. It's a technique that is used for directing or the transmission of a radio signal to a specific device. The device has been designated for a specific data that is being transmitted. That technique is called beamforming. Now, the benefit of this is increasing data throughput while reducing power consumption. That's why we have the standardized one, which is called the multiple user MIMO, has solved the problem of power consumption. So it reduces the power consumption by using what we call standardized beamforming. By using what we call the standardized beamforming, sending only direct transmission signal, radio frequency signal or radio signal to only a specific device that is meant to, not send it to super broadcast it to multiple devices. The message or the data will only be delivered to the device that is designated in the first place. That's what we call the beamforming. Okay, now the transmit range of the 802.11 AC is similar to or even better than the 802.11 N. They are similar to that of N, but could also better than the 802.11 N. Now let's talk about Wi-Fi briefly. You remember Wi-Fi means wireless fidelity, and we said this is regulated by what we call the Wi-Fi Alliance. Okay, the Wi-Fi Alliance regulates the testing procedures and gives certification for wireless equipment that are compliance with the 802.11x standard that is used in the wireless network. Okay, now we say the 802.11x is the group of wireless standard developed under the IEEE 802.11 standard. Now let's move on quickly. Now let's look at the wireless standard. The wireless standard is similar to all the standard I've mentioned in my earlier talk. Now, when we say 802.11a, it means wireless A. It means wireless A. Now, let's take a look at the distance, the range, the cover, the speed, the bandwidth, and everything, and the technology that is used for modulation. Let's talk about it briefly, summarize them here. Now, we say the 802.11a, this standard provides data transfer rate up to 54 megabit per second. So a speed of 54 megabit per second and also operating range up to 75 feet. It can cover a distance of 75 feet with a speed of 54 megabit per second, and it operates at a bandwidth of 5 gigahertz. And the modulation technique is OFDM. Orthogonal frequency division multiplexing is the technology that is being used for transmission, that is being used for this modulation. The technology for modulation for transmission is the OFDM, which is orthogonal frequency division multiplexing. And then we say the distance it covers, the wireless 802.11a can cover a distance of 75 feet and a speed of 54 megabit per second. Now let's talk about the second one, which is 802.11b. The 802.11b is called wireless B. This wireless B, these standards provide data transfer rate up to 11 megabit per second. The B covers 11 megabit per second with a range of 100 to 150 feet. It can cover a distance of 100 feet to 150 feet. It operates in 2.4 gigahertz frequency bandwidth, and the modulation techniques that is used before the data is being transmitted is called the DSS, direct sequence spread spectrum. It uses what we call the direct sequence spread spectrum. Okay, the 802.11b uses what we call the technology called for modulation called the direct sequence spread spectrum. Now let's go to G. 802.11g, the wireless G. It's also called wireless G. The wireless G, this standard can provide data transfer rate up to 54. It takes from the 54 of A and also takes the distance of B. The 54 of A and the distance transfer rate of B, which is about 150 feet. It operates in the 2.4 gigahertz bandwidth, and the modulation techniques is either DSS or OFDM. So you can either use the direct sequence spectrum or use the orthogonal frequency division multiplexing. Okay, so you can see G is an improvement of A and B. It's a dichotomy. between A and B. Now let's move on quickly. 802.11n is a super improvement or a next level wireless. N is the next level in the family of wireless network. Now this is the next generation of high-speed wireless connectivity, which uses or transfers high data rate over or above, well above 200 megabit per second. You can see this is a huge improvement. Not 54 this time around, over 200 megabit per second. Could be 240 megabit, 250, up to 300, and so on and so forth. It operates at a 2.4 gigahertz bandwidth and also 5 gigahertz bandwidth. So the end can use both. 2.4 is compatible with 2.4 bandwidth and 5 gigahertz bandwidth. Now the modulation is also both of them, so which means it's similar to G, but it's an improvement of G. 802.11g. This is an improvement of 802.11g. So we say 802.11n is a super improvement of 802.11g. So it uses the modulation techniques is direct sequence spectrum or the orthogonal frequency division multiplexing. Okay, now let's go to the 802.11ac. The 802.11ac, this is the next generation of high-speed wireless connectivity. The technology promises data rate up to 1 gig. Okay, we hope we can achieve this. This technology is promising data rate up to 1 gig, and it operates over the 5 gigahertz bandwidth. Okay, so you see this is a super good one because the speed is next to nothing. You know, you cannot. There's nothing to compare with this. There's nothing that is comparable with this. This is super high speed. Okay, and it's operating at a 5 gig bandwidth. Now let's talk about the 802.11i. The 802.11i talk about the encryption. The standard for wireless LAN, that's the WLAN, provides improved data encryption for networks that use the 802.11a, 802.11b, and 802.11g standards. So this is like providing a platform for ability to encrypt every data that is sent across 802.11a, b, and g. That's what we call the 802.11i. Now let's talk about the 802.11r. The 802.11r, this standard is designed to speed the handover between the access point or cells in the wireless local area network. This standard is a critical addition to the 802.11 family or the 802.11 wireless LAN if voice traffic is to become widely deployed. If we want to consider the usage of voice in our data transmission, then this 802.11r is a good one because it's going to look at the access point and how they be used from cell to cell in our WLAN. Is that okay? Now let's move on quickly. Now let's take a look at another layer. We finished the physical layer in this chapter for the IEEE standard 802.11 family. Now let's take a look at the MAC layer. The MAC layer, which we call the media access control layer, defines the reliability of the data service. Also look at the access control that is shared with the wireless medium, and then also look at protecting the privacy of the data that is transmitted. So we're looking at protecting the privacy of data transmitted. We're looking at how we can control what we shared with the medium, and we're looking at the system reliability of the data service. Okay, now let's move on quickly. Wireless management protocol, the third layer in this chapter, looks at the wireless management protocol service. One is authentication, second is association, third is data delivery, and fourth is privacy issues. Now let's take a look at the basic service set. The basic service set is a topology of wireless local area network that is used with the wireless local area network, as it were. The basic service set, BSS, is also called the independent basic service set, which is called the ad hoc network. So an example of an ad hoc network is this one that you see on the screen. An example is this one that we are showing on the screen. Is that okay? So now in this network, the wireless client station communicate directly with each other. So this computer A can communicate with computer C, And this computer A also can communicate with B, B can communicate with C, C can communicate with A, and vice versa. So they can communicate with each other. Okay? This means that the client have recognized the other station in the wireless LAN and have established a wireless data link between each of these devices in the network. It has established a linkage with them and it's able to communicate with them. So that's it for this basic service set. Now let's take a look at the access point that is created when we are using a basic service point. Now the performance of the basic service point can be achieved by including an access point. How is that? Because in most networks we have both wired LAN and wireless LAN. In many cases, in most places, in big organizations or in big metropolitan area, we have both wired LAN and wireless LAN. So in that case, every time we have a wired LAN and wireless LAN, we need to have an access point that is connected to the wired LAN, the wired local area network. This access point, once it's provided, then it's able to also communicate with the wireless one. PCA is a wireless one. PCB is a wireless network. PCC is a wireless one. PCD is a wireless one. PCE is a wired network with an access point. Now, the reason for this access point, the reason why we provide this access point is to enable connectivity between wired network and wireless network. Once you have an access point, you are able to provide communication between wired network, wired local area network, and wireless network. Now, the access point typically uses an RJ45 jack for connecting to the wired network. If an access point is being used, then the user establishes a wireless communication link through the access point to communicate with other users in the WLAN or in the wired network, as we've shown in this diagram. So the essence of the access point is to establish a communication between wired network and wireless network, as we've shown in this diagram. Okay, now let's move on quickly for the sake of time. Now let's take a look at the basic service point problem. The problem we have with basic service point is that sometimes the user can be in motion, can travel. The user may be traveling. For example, if you are traveling from a place to place, let's say you are traveling from Calgary to Vancouver, you are moving. As you're moving from one station to another, or you're traveling from Cambridge to Boston in Massachusetts in United States, as you're moving from one location in Massachusetts, in the state of Massachusetts in United States, then the user will gradually move away from this access point, may no longer receive a strong signal from this access point. Okay, may no longer receive strong signal. Let's say if the user is here now, you can see that the user is now closer. The user is now closer to access point 2 than access point A. So the basic service set, the way it has been designed, the user will automatically, not manually, automatically switch to access point 2. We now start receiving signal from access point 2 instead of access point 1. The user will start receiving signal from access point 2 instead of access point 1. As you get closer to Vancouver, let's say you're coming from Calgary in Alberta, Canada. Let's say you're coming from Calgary in Alberta, Canada. You will see that this user is gradually moving away from the access point in Calgary in Alberta to this access point in somewhere closer to Vancouver. Maybe we can say Surrey. Let's say there is Surrey in British Columbia, in closer to Vancouver. So as you get closer, as you move away, let's assume this point is Vancouver. This place is Vancouver. As you come here, your service will automatically switch to the access point here. Will no longer be receiving service from access point A in Calgary. You will no longer be receiving service from access point A in Calgary. You start receiving service from access point A in Vancouver. It will switch automatically to access point 3 in Vancouver, not access point 2 in Surrey or a place closer to Vancouver. Neither is he going to receive access point from receive signal from access point 1 in Calgary. Okay, so that's it. The problem is created. Therefore, to solve or mitigate against the problem, we have to have what we call extended service set. Extended, what we call the extended service set. Extended service set is to create multiple basic service set, to create multiple BS, what we call, like what you used to call the mask, the communication mask. You have to create more of it, so that as you travel, you begin to get signals you travel along the path, okay, in your journey. So that's how to mitigate against the problem. To mitigate against the problem caused by the basic service set is for us to create an extended service set by creating multiple access points along the way, and covers the range of places where people normally live and where people travel to in a given country or given location. Now let's move on quickly. Okay, so we said the mobile computers will establish an authorized connections with the access point that has the strongest signals level as you travel on the journey. Is that okay? So this is an automatic process for all the wireless client adapter in 802.11 family. All the wireless adapter has to automatically switch to the access point closer to you as you travel within a given location. Okay, we can use another place. Let's say you're traveling from Lagos. Let's say this is Lagos. Okay, let's use Africa, Lagos, Nigeria. And this is Abuja. Okay, and let's say here is somewhere, let's say Edo State. Okay, so from Lagos, as you move away from Lagos, you get it to Edo State, your service will switch to this access point in Edo State. Your service will switch to this access in Edo State. You will no longer be using the service from Lagos. You will no longer be using the network from Lagos, although it's the same network, but they have multiple access points created for basic service point. So as you get to Abuja or closer to Abuja, somewhere in Lokoja, when you get to somewhere in Lokoja in Kogi State, you start switching to this access point 3 of Abuja. You start switching to this access point 3 of Abuja. Is that okay? So you will no longer using the access point of Lagos, neither will you be using the access point 2 of Edo State. You start using the access point of Abuja. So this is the point I'm trying to explain with this. Okay, now let's move on quickly. Now let's take a look at the network access point, or the network access in all the 802.11 family. They use a technique called the carrier access multiple access, CSMA, the carrier access multiple access, or what you can also call collision avoiders. They use what we call this CSMA, or what we call the collision avoiders, so that there will be no collision between the data that is being transmitted within the different access in the IEEE 802.11 family. Now in CSMA or CA, the clear station listens for other users of the wireless network. If the channel is quiet, the clear station may transmit, and if the channel is busy, the clear station may wait until the transmission stops before he can transmit his own. So this is how they avoid collision, or this technology is called CSMA, carrier sense multiple access. They will sense if the carrier is busy. If the carrier is busy, they will sense it, and then they will be able to avoid it and stop to transmit. But when it's free, they will be able to transmit. Is that okay? So that's it. Now let's move on quickly. So with that takes us to almost the end of this section. We say each clear station uses a unique random back-off time. A unique random back-off time. Back off. Back off. The channel is busy. Back off. Channel is busy. Back off. Randomly. Pseudo randomly. Okay. Probabilistically. Okay. So it uses this so that the techniques prevent the clear station from transmitting to gain access to the wireless channel as soon as it's when it's busy. It can only access it when it becomes quiet. Okay, so that takes us to the end of this section. Now let's take a look at the things we have looked at. We've talked about the basic service set. We've talked about the ad hoc. We talked about the access point. We talked about the transceiver. We talked about the extended service set using multiple access points to solve the problem by the basic service point. We talked about the carrier sense multiple access. We talked about the DSS and the ISM, and then we talked about FH, frequency, Hopi, spectrum, pseudo random. We talked about Hopi sequence, OFDM, orthogonal frequency division multiplexes, U9, MIMO, multiple input, multiple outputs. We talked about multi-user MIMO, beamforming, the method of transmitting radio signal to only a designated device. We've talked about all of this. Okay, so with this brings us to the end of this section, chapter 4, part 2. Thank you very much. Thank you very much.